So let's graph a quadratic function. And the graph of a quadratic function is a straight line. It's a smooth curve, and we call it parabola. Let's start with f of x equals x squared minus 3. There are some key points that we need to find in order to graph a quadratic function. One of them is the vertex. Vertex is the lowest or highest point of a quadratic function. Sometimes we call it the maximum or the minimum point. And there are two forms of quadratic functions. One form is the vertex form. Let me write it here. The vertex form of a quadratic function is given by f of x equals a times the quantity x minus h squared plus k, where the point hk is your vertex. And that's what we need to find first. Whenever we graph a quadratic function, we have to find the vertex. If your function is in vertex form, then you can easily find your vertex. We have here x squared minus 3. All right. So that's why f of x equals x squared minus 3. Now graphing this function, f of x equals x squared minus 3, we can say that it's in the vertex form, right? So what's your vertex for x squared minus 3? It doesn't appear to be a times the quantity x minus h squared plus k, since we do not have h here, right? So we do not have h because that h is 0. You don't see that, right? This one is a, the coefficient of x minus h. So if we can write it this way, a, what's your a here? It's the coefficient. It's 1 times x minus, what do you think is in here? It's 0, right? And that will be minus 3. So it appears to be a times the quantity x minus h squared plus k, with h, which is, right, well, what do you think is this? This is h, this is k. So what's your h here? It's gonna be 0. And what's your k? What's your k? It's negative 3. Remember, we're looking for the hk. So this should be written as x minus. And after minus, it's your h. And what's after minus? After minus, it's 0. And then here, whatever sign you have for the constant term, that would be your k. That would be the sign of your k. So it would be 0, negative 3. Therefore, in that case, your vertex is the point 0, negative 3. It's the point 0, negative 3. Now let's find other points. It's happened that when you factor x squared minus 3, you can find the intercepts, but we cannot find the intercepts by setting y to 0. Because x squared minus 3 is not vectorable. So in that case, our intercepts could either be imaginary or it could be irrational. Since we cannot vector it, then we can find other factors, other points aside from the intercepts. And one of the point that we have here is already your vertex 0, negative 3. So let's find other points. What other points can we have here? So x, y. Vertex is one of the point. We already have 0, negative 3. Let's find 4 more points. Let us find 4 more points here. But it would be good if we can plot 0, negative 3 now. 0, negative 3. Where's 0, -3? So we know where the vertex is. This is 0. We count 3 units below. 1, 2, 3. So we have your point there. This is your vertex. 0, -3. One characteristic of a parabola is that it has an axis of symmetry. The axis of symmetry can be a line. It can be drawn as a line, and it divides your parabola into two equal halves. So we can also draw that axis of symmetry. And what's the axis of symmetry here? The axis of symmetry here can be obtained using your vertex. And let's write the axis of symmetry. Let me erase this first. So we have enough space for the axis of symmetry. Your axis of symmetry is x equals h. And since h is 0, that means x is equal to 0. That's your axis of symmetry. We have your vertex here. Okay. This is your vertex, 0, -3. The axis of symmetry is a vertical line that passes through your vertex. So we can draw this line x equals 0. So let's draw that line x equals 0. So where is x equals 0? And so the vertex here, let's draw a vertical line, dash line, and that's your axis of symmetry, x equals 0. The axis of symmetry has a very important role because it divides your parabola into two equal halves. And that will be our guide in sketching the curve of our parabola. Now we can find other points. You can now find other points aside from your vertex. All right, so let's create a table of value after finding your vertex. After finding your vertex and your axis of symmetry, which is x equals h, and that's x equals 0. Let's now find other points. In this table, we can put the first point that we have, 0, -3, which is this, which is the vertex here, 0, -3. We need 5 points so that we can graph accurately a parabola. Okay? And we can use the intercepts, we can use the y-intercept. How do we find the x-intercept again? Note that f of x can be written as y. And so we can write f of x as y equals x squared minus 3. Okay. So let's find your x-intercepts. I think we need more space. I'll just add another slide for the x-intercept. In order to find your x-intercept, we let y be 0, right? So we now use this y equals x squared minus 3. Note that our equation is y equals x squared minus 3. So when we let y be 0, we have 0 equals x squared minus 3. It so happened that x squared minus 3 cannot be factored, right? So that means that your x-intercept can either be irrational or imaginary. And so let's not use this. But we can find another intercept. And that is your y-intercept, right? Let's have the y-intercept. In order to find your y-intercept, here we let x be 0. Remember that our equation here is y equals x squared minus 3. So we have y equals 0 squared minus 3. Therefore, y is equal to 0 squared, 0. 0 minus 3, y is equal to negative 3. All right, so that's one of our points. You have x0 will be 0. Okay, cannot write. 0, negative 3. So now we can put here 0, negative 3, but that's actually your vertex. And so your vertex happens to be your y-intercept. So it's the same point as 0, negative 3. That means we need to find other points aside from the x and y-intercept. We cannot make use of the x-intercept because we cannot factor, although we can look at the x-intercept later on. But for now, we cannot use the x-intercept. The y-intercept is 0, negative 3, which is the same as your vertex. So you don't have to put that again. Now we can find other points. So let's assign values for it, just like what we usually do when we graph a line. You can assign any values of your x. We can put, okay, tell me what we can put. We can put 1. Okay, we can put 1 here. What else? We can put 2. All right. So if your x is 1, if your x is 1, what is your y? So let's try that. X equals 1. Remember that we can replace f of x by y, so let's solve for y. We have y equals, if your x is 1, you have 1 squared minus 3. It's 1 squared. It's going to be 1 minus 3. So y is equal to negative 2. So we have negative 2 here. Next point. We need to solve for y also when your x is 2. So let's write that. Let's have it here. If x equals 2, what's our y? Let's solve. Y equals 2 squared minus 3. What's 2 squared? It is 4 minus 3. Y is 1. I can put now 1 here. Now we have 3 points. Like I said a while ago, we need 5 points. But we have to find 2 points. I mean, some points on this side and some points on that side. Can we plot 1, negative 2 now? Well, let's plot 1, negative 2. Where is 1, negative 2? It's somewhere here. So 1, 1, 2. So we have this point, 1, negative 2. Now we also have 2, 1. 2, 1. Where's 2, 1? 1, 2, 1 there. So here, 2, 1. 1, negative 2. And then 2, 1. Now, this is the purpose of your axis of symmetry. You see this orange dashed line here? It is the axis of symmetry. It divides your parabola into 2 equal halves. Now we have 2 points on this side. We can make use of these points to find other points, because each of these points on the other half has a mirror image point. All right, let's look at this. This point has a mirror image point. That means it has a point with equal distance from your axis of symmetry. So if this is the point, then there's a point here with equal distance. Right? If that is a point, then there's a point with equal distance. 1, 2. So we count 1, 2. There's a point there. All right. So now you don't have to solve. You only need 2 points on the left side, and then you can get the other points on the right side. That's why we need to draw that axis of symmetry. If you want, you can solve for that, but I advise that you don't solve it. You just count. You just look for mirror image of each point on the left or on the right. If you have a point on the right, then find the mirror image here. So this is the point, right? And this one as a mirror image point here. And you can add that to your table of values. Can we add it to your table of values? Yes. Okay, let me just let us minimize this. So I can write all the 5 points, including the mirror image. We have 0, -3, we've put 1, -2, we've put 2, 1. We have 2 spaces for the other 2 points, which are the mirror image. So what do you think it's the coordinates of this point? It's gonna be -1, -2, right? -1, -2. How about this? Tell me the coordinates of this. It's gonna be -2, -2, 1. See, we were able to get that without calculating any value. We only use the mirror image. And so we have to write it here, -1, -2, -2, 1. And now we completed the 5 points. 5 points needed in order to graph your parabola. All right, so let's connect your points. Let's connect your points. We have here a smooth curve connecting all the 5 points. And now, oh, that's so ugly. So let me draw it better. All right, so that's your parabola with the 5 points. Now that's this is the graph of x squared minus 3. If you want to have other points, you can calculate, just assign your values for x. Just assign your values for x. Just remember, in order to graph a parabola, you must find the vertex first. You can also use the x and y intercept to find the points. If it's not possible to find the x-intercept by vectoring, then you can use the y-intercept, or if not, you can solve for y value, but you need to assign 2 or 3 values for your x. And then find the mirror image of those points on the left. If you have points on the left, or if you have points on the right, find the mirror image. Just make sure you draw the axis of symmetry that will intersect your vertex. The vertex is either your lowest point in the graph or the highest point in the graph. And now this is our parabola.